Welcome back to AI in 5 minutes a day. Today we're tackling one of AI's weirdest quirks. Ever wondered how AI can recognize a cat, even if it's never seen that cat before? In this episode, we'll break down how AI analyzes patterns instead of truly understanding concepts and the insane amount of computing power needed to make it all work. We'll also dive into whether AI actually knows anything or if it's just a really advanced guesser. By the end, you'll see why AI is less of a thinking machine and more of a data-obsessed scientist. Let's get into it. So why can AI recognize a cat, and can it actually understand what a cat is? Spoiler, not really. How does AI know a cat is a cat? It spots patterns in ear shapes, fur texture, and facial features that make a cat, well, cat-like. It can differentiate cats from dogs, fine. It can even distinguish animals from non-animals, which is a whole different challenge. So while AI might not love cats, it's very good at identifying them. But, does AI actually understand anything? Philosophers have spent centuries debating what makes a chair, so good luck expecting AI to have a deep answer. AI doesn't understand cats. It just calculates statistical similarities. It's all about geometry and probabilities, not actual reasoning. AI clusters similar things together based on past data. Think of AI as a very advanced pattern spotter, not a deep thinker. But then how does AI see? Spoiler alert, it doesn't really see. Or at least AI doesn't see like we do. It crunches numbers. It breaks images into grids of pixels, millions of tiny dots with color values. Recognizing a cat means sorting through millions of variations, a massive math problem. Brute force computing isn't enough. It needs structure to make sense of data. Imagine trying to solve a jigsaw puzzle with no picture on the box. That's AI, but with way more math. So why is AI suddenly so powerful? Now we're getting into the role of raw computing power. It's quite simple, and you can summarize it by better algorithms, AI got smarter; more computing power, AI got faster; bigger data sets, AI got more data to learn from. AI in the 1970s, 80s was like trying to teach a toddler advanced physics. AI today? More like a supercomputer with a photographic memory. But it still makes dumb mistakes, just faster and with more confidence. So we said before that AI was more of a data-obsessed scientist, and here is why. AI doesn't think. It detects patterns. Instead of being programmed with knowledge, it extracts knowledge from data. It's less of a rule follower, more of an experimenter. So next time AI makes a weird mistake, just remember, it's still learning, kind of like the rest of us. So now, let's get a bit more technical. Ever heard about large language models? They're the main reason why AI is indeed smart, but not that smart. First, what are large language models, or LLMs? LLMs, like ChatGPT, DeepSeek, and Gemini, are basically giant text prediction machines. They don't actually understand language, they just predict the next most probable word based on statistical patterns. They don't learn grammar the way humans do, they absorb it indirectly from massive data sets. The meaning of a word comes from its context, how it appears relative to other words. Think of it as a really advanced autocomplete that just happens to sound intelligent. Then, how do LLMs process language? Words turn into numbers that then turn into geometric space. LLMs convert words into numerical vectors and map them in a multidimensional space. This allows AI to find relationships between words, making translation possible without directly comparing grammar rules. Translation? For AI, it isn't about knowing the rules of French or Spanish. It's about finding patterns between similar words across languages. Now, why are some new LLMs more efficient? DeepSeek AI, a Chinese startup, made LLMs faster and smarter by dividing models into specialized expert modules, reducing computational cost, and using reinforcement learning, like AI playing chess or Go, to refine reasoning. So instead of burning through ridiculous amounts of energy, these AI models are learning to work smarter, not harder. But then, are LLMs actually intelligent? Meta's AI chief, Yann LeCun, has some thoughts. LLMs are great at generating text, but bad at understanding the physical world. They lack causal reasoning, meaning they don't get cause and effect relationships. They can pass the bar exam or mimic Victor Hugo, but ask them to do your laundry? Forget it. So yeah, LLMs can sound smart, but relax. They're not about to replace you. And that's a wrap for this episode of AI in 5 minutes a day. Today we broke down how AI recognizes patterns, processes language, and why, despite all its advancements, it still doesn't actually understand the world like we do. But we're just getting started. Next episode, we're diving even deeper into AI's evolution, where it's going, how it's shaping the future, and what we can actually do with it. Don't miss your next quick, no-nonsense dive into the world of AI.